start the recording and we'll see how much we can go. So just for a quick recap, what we have seen in our last class was somewhat like this. Okay. The key content was that the gradient of any graph is given by del y by del x, which is simple. We can have two types of gradients. We can have positive gradients for graphs where y value increases as x value increases, or we can have negative gradient graphs where y value decreases as x value increases. So these actually determine whether the gradient is positive or negative. That's the first thing that we have seen. And the other thing that we have seen is that which part of the curve is more steep and how does the steepness of the curve changes as we observe the graph with an x value increasing. So from left to right, what is happening to the curve, what is happening to the steepness of the curve. So whether the m value, the magnitude of m, is it increasing, is it constant, or is it decreasing? So we have considered these factors as well. The other variable that the other part that I told you, that whenever we are judging the gradient of any graph, what is important that we will eventually learn all of these parts throughout our syllabus, piece by piece. It's going to work out. But for any graph, the gradient quantity basically represents the quantity that is given by the y-axis quantity divided by the x-axis quantity. So if you have a displacement time graph, in that case, the gradient will give you velocity. If you have a distance time graph, the gradient will give you speed. If you have a velocity time graph, the gradient will give you acceleration. If you have a what can I say? If you have a force versus extension graph, the gradient will give you spring constant. If you have a work done versus time graph, the gradient will give you power. If you have a force versus area graph, the gradient can give you pressure. So this was power and this is pressure. They're both signed by P, sometimes capital P, sometimes small p, depends upon the question. So you have to understand from your understanding of physics, we'll see the definitions for relevant chapters slowly, will go on forward, that which of these quantities represent which quantity. And one thing is also really, really important, that you have to understand these relationships are applicable whenever the gradient, whenever the gradient quantity is actually represented by the del y by del x. If there is such a relationship, whether any quantity is directly related by y by x, that would not be gradient. Now you might wonder, what does that mean? There are some few relationships which are we're going to see in the electricity chapter. Resistance is given by the quantity V by I. It is full voltage divided by full current. Resistance is not given by change of voltage divided by change of current. So if we have a VI graph, if we have a voltage versus current graph, the gradient of any curve at any instantaneous point doesn't give the resistance of that point. It is measured by the origin joining straight line. So it's a bit of a different story. So I'm not gonna bother you with this discussion right now. So এটা আমরা eventually যখন actual chapter আসবে আমরা ওই সময় দেখবো. I gave you a small bit of a homework where I asked you to write the description for displacement time graph for the graph that looked somewhat like this. Maybe we have a straight line, we have a curve, then we have it lower, then we have another curve, and then we have a straight line finishing down. So the points were labeled somewhat like this: O, A, B, C. Was it like that?
Yes, sir.
Last কি D ছিল?
D ছিল, হ্যাঁ স্যার।
Last ছিল D. So I asked you to attempt to write the description of the motion of this object for which this displacement time graph was given in terms of the gradient variation. So You might have written different explanation, which is perfectly all right. I asked you to send me the written version, take a picture to my messenger. Did I ask you to do that? Maybe I didn't.
No, sir.
Actually, I didn't. So disregard that. I'm going to tell you the description of these individual parts from my own. I want you to check it with your written description, provided that you have attempted the homework. And if any of the part does not match, or if there is a different set of wording which altogether means different that you understand, or you have some confusion about a certain part of the description, you ask me immediately. Raise your hand or just ask the question directly in the channel. Perfectly works. So what happens here? I'd like to see one more thing. আচ্ছা মুস্তাহসিন সমস্যা না আছেও না চলে গেছে তার সমস্যা নাই রেকর্ডিং দেখে নিলে হবে এখানে তো কোনো অ্যাড রিকোয়েস্ট নাই অ্যাড রিকোয়েস্ট আছে কোনো না এখানে কোনো অ্যাড রিকোয়েস্ট নাই ওকে দীপ্র ওয়েলকাম
Hello, sir. Am I audible?
তুমি তো চিটাগাং দীপ্র রাইট
It is, sir.
আচ্ছা ঠিক আছে ক্লাসটা করো কোনো কোশ্চেন থাকলে ইউ আস্ক মি ইমিডিয়েটলি নো বিগ ডিল সো অল কোশ্চেনস আর ওয়েলকাম এট এনি পয়েন্ট নো বিগ ডিল
Yes, sir.
So if I was writing the description for this displacement time graph, this is how I would go. For the segment OA, I'd write, I'm gonna just dictate it so you try to understand from the graph. I'd say the object starts with some initial velocity. The velocity of the object gradually reduces to 0 at point A. So what I mean by that, exactly at the starting point, you have some exact value of gradient, and you can see that this gradient is slowly becoming slanted as you slowly start to observe the graph over and over here. At A point, this is one of the peak of the curve. So if you have a tangent over here, this gradient line, this tangent, would actually mean that the gradient exactly at this point is 0. Now, because we have drawn a displacement time graph, the gradient of displacement time graph, which is delta d over delta t, actually gives us velocity. So that's why I'm talking about in terms of velocity. So I'll say it again. The object starts with some initial velocity, and the velocity gradually reduces to 0 at point A. Then from A to B, I'm gonna say, now what is happening to A to B? This is the part that you need to understand. Have a look. At A, the object is at 0 velocity. It means the object was moving forward, then it stopped. So if you try to physically visualize the object's motion, I'm not, I cannot actually, maybe I can. Let's say this is the starting position of the object. Let's say this is our O point. The object, at this point, the object has some significant initial velocity towards right. Let's say towards right is the positive direction. And as it moves from O to A, it actually slows down slowly, and eventually at a point A, let's say this point is somewhere over here. At point A, it comes to rest. Now, what happens afterwards? Now, from this point, if you observe from A to B, you should see that the gradient of this curve is actually becoming negative. So up till now, for this much segment, the gradient was positive, and it was instantaneously 0 at this point. This is the highest point of the curve. And on the right side of this A point, the graph is actually becoming on the lower value, which means from this point on to this point, there is a decreasing pattern. So for all of this point, for all of this segment, AB segment, the gradient would be negative, which means we're going to have a negative velocity. So that would mean the object would slowly start to move in the opposite direction, because now the displacement is going to slowly become less, which means, let's say this was the object over here at initial point O, it moved to A, and then from A to B, the object is going to start moving backwards. And over here, you can see that B is not essentially close to O. It has some value before it reaches A. So I might as well plot B point over here. I'm just roughly sketching this point, so don't consider the scale. I mean, these figures are not drawn to scale. I'm just trying to give you the idea. So from A to B, the object is going to move towards left. Why am I drawing it up to B? Because I can see once again, exactly at B point, the curve is once again having a lowest point. It means that if we do draw a tangent right over here, this line is going to represent once again a gradient of 0, which means the object is going to start going in opposite direction. It's going to move through this point, but eventually at this point, once again, the velocity will momentarily become 0, or the object will momentarily come to rest. Momentarily means that it just stops and then it starts to do something else. It just doesn't stop and remain stop for a measurable duration of time. Momentarily concept আমি তোমাদেরকে আরেকভাবে দিতে পারি। একটা সিম্পল জিনিস বুঝাই, মানে ইনস্ট্যান্টেনিয়াস or momentary ওয়ার্ডটার ফিজিক্যাল সিগনিফিকেন্স একটা খুব ভালো এক্সাম্পল আছে। সেটা হচ্ছে, have a look, let's say we have an object, this is the ground. আমরা মনে করি এখান থেকে একটা অবজেক্ট, গ্রাউন্ড থেকে একটা অবজেক্টকে ফিজিক্যালি কোন একটা মেকানিজম দিয়ে ভার্টিক্যালি আপওয়ার্ডস থ্রো করলাম। তো তার একটা ইনিশিয়াল ভেলোসিটি আছে, আর তার উপর অ্যাক্সিলারেশন হচ্ছে -10 মিটার পার সেকেন্ড স্কয়ার। I'm giving minus because I'm considering the upward direction as positive vector. So this initial velocity is positive, and the acceleration due to gravity, which is going to work vertically downwards. So that's what is represented as -10 meter per second square. So as the object will slowly keep on rising, it's going to slow down, slow down, slow down, slow down, and eventually it's going to come to its maximum highest point, and then it's going to start falling downwards. Now, if I ask you, how long does the object remain stationary at the highest position? What is the duration of time for which the object remains in the highest position? What would your answer be?
It stops momentarily.
That's the correct answer. But in many cases, students tend to give some duration value. There is a reason for this. Whenever the object rises up through this point, it actually is seen to move pretty fast. But as it comes to zero velocity, it moves so slowly that our eye actually gets the sensation of the object pretty much at the same position for a measurable duration of time. And that's why sometimes it might feel to our brain that the object apparently remains there for maybe for a fraction of a second. But that is not correct. I'll show you why that is not correct. The object actually reaches up to zero velocity and it immediately starts to fall down. Here is the reason. If I try to draw the velocity time graph of this object, let's say this initial velocity was maybe, let's say 40 meters per second. I'm using 40 meters per second because this is a good multiple of 10. So how this graph is going to look like? If I plot this graph on a VT graph, so the initial velocity is 40 positive, let's say 10, 20, 30, 40. So it starts from here and it's gonna lose 10 meter per second of velocity every second, because 10 meter per second means it's gonna have an acceleration of 10 meter per second per second. The change of velocity every second will be measured to 10 meter per second, because in this case the acceleration is working in the opposite direction of initial velocity, so the initial velocity will be becoming less over time. So let's say this is v given in meter per second, this is t given in second. Let's say this is our 40 initial velocity, and let's say each of these horizontal directions, actually I can actually try to draw the horizontal axis a bit better. Maybe eraser select হচ্ছে না কেন? So maybe I'll try to draw the horizontal axis somewhere over here.
Sir,
Yes,
so which chapter is it again?
motion.
Motion. Sir, do you have any books for it, or?
Yeah, you can buy the regular textbook. That is the Cambridge physics book that you can have, or you can have the green covered book, which is physics second edition. It is published from Federal. It is already published from McGraw-Hill. The writer is, I think, Po Leong Young, something like that. I'm talking about this book. Hold up. This is your course book that is directly published from Cambridge Press. You can have this. This is the most common book that we teachers used to teach before Cambridge started to publish their own book. This is the Cambridge endorsed book. And for additional content, if you really want to go into much better understanding by reading significantly bigger version of a certain discussion, but not necessarily difficult, you might as well consider the Abbott book. which has a cover that looks like this. If you have access to this book, this is actually the view of a Doppler effect and bit of a Doppler effect, and also we have the sonic boom represented. So this is also another book for the edition at AF Abbott. You can also have access to this book. These are the books which should be good enough. If you have even one of them, it's perfectly all right. All right. So if I consider the time variations over here, let's say this is 1 second, and this is 2 seconds, this is 3 seconds, this is 4 seconds. The way this graph is going to work by that, after 1 second, the velocity is going to be 30 meters per second. After 2 seconds, it's going to be 20. After 3 seconds, it's going to be 10. At 4 seconds, it's going to be perfectly 0. And if I draw this graph just like that, this graph is going to be a straight line that passes through the to this point, and eventually it will be continued further on. The reason it will be a perfect straight line, because gravitational force on the object keeps on working on this object continuously. It doesn't stop to work at any point. When the object reaches maximum height, at this point, it's not going to remain stationary over here for a certain duration of time, because that would mean what? The object has reached up and it is just now levitating maybe for some duration. That would essentially imply that the object has lost its weight for the duration, because the earth is not pulling it anymore. As long as the earth is keeping on pulling it, so it means for the entire journey of this object till it reaches the ground once again, is going to have the same gradient of minus 10 meters per second squared, which is basically the value of g. And on this axis, this is a perfect crossing of these two lines. Now, because of the limitation that we have for a physical system, that our lines have thicknesses, but if you think for a really perfect graph, if this is your x-axis, this is your graph, this is going to be a perfect dot. Your graph is not going to look like this. If this is your x-axis, your graph will never look like this, that the object reaches the highest position, remains stationary maybe for a duration of time, and then it starts to go down. You're never going to have a situation like this. This is not going to happen, because if the object actually stayed at the top, there would be some horizontal segment representing that steady duration time where it's not moving at all. That's not the case. Momentary, the word momentary means that it happens, but the duration for it happens is 0. Do I make sense? Bolaban,
Sir, could you repeat it? I was unable to understand.
Sure. The word momentary means that something happens in the continuity of events, and its happening is defined, but the duration for which it happens, that measure of time is 0. I mean, it does happen, but it doesn't happen for any measurable duration of time. It just happens. So if I say that, did the object come to rest in this upward and downward motion? The answer is yes. If I ask that for how long the object was at rest, that answer is 0 second, and it's perfectly 0 second. That's what we mean by the word momentary, that it happens, but not for any duration. Bucho?
Yes, sir.
Beautiful. So what happens for this graph at B point, the object actually slows down. It starts to go backwards because the displacement is reducing. And for this entire part, the gradient will be negative because we have the y value decreasing as the s value increases over here. So as the object further, as time goes by, the object is gonna start from A, from rest, momentary rest, and eventually it's gonna come to B at momentary rest as well. So, and also if you look at this entire segment of AB, you should see that this part has the highest or steepest line somewhere in the middle. So here you're gonna have the highest negative velocity, and here, and then the negative velocity slowly reduces, and eventually that velocity comes to 0 exactly at this point. So for segment AB, I could write my description like this. Object starts to move backwards because it has negative velocity. Object starts to move backwards. It speeds up for the first half, and then slows down for the next half, eventually come to rest at position B. I'll say it again. This is the description for the object's motion for AB segment. I'll say it again. Have a look. Try to understand. The object starts from rest, and moves backwards. I'm using the term backwards because in this case, the object is now actually moving from A towards O. So the object starts from rest and starts to move backwards, full stop. It speeds up for the first half of the duration and then slows down to rest for the next half of the duration. We're talking about only AB, so that's what is happening. Now, whenever I say speeds up, what do I actually mean? I mean that the object's acceleration is happening. It is having a bigger movement speed. But because the object is actually moving in the negative direction, that's why I'm not bothering to mention that the negative velocity increases and then the negative velocity decreases. You could also write that as well. I mean, if you do write that from at A, the object is at rest, from A to B, the object moves with negative velocity. For the first half, the negative velocity increases, and for the next half, the negative velocity decreases. Ultimately, at B, the velocity of the object is 0. That is also perfectly all right. If you mention the word negative velocity, you are perfectly good. This is a perfectly acceptable and good quality description as well. I'm using the term speeds up to give a much vivid physical description for what is happening to the motion of the object. Because at the beginning, at the first sentence, I said that the object is going to move backwards in the first sentence. By that definition, I have already defined the direction for what is happening for the segment of AB. বুঝা গেছে?
Sir, since we are mentioning the direction at the beginning, can't we use that its velocity increases instead of negative velocity?
Yeah, you can totally say that. I said speed increases, you can say velocity increases. Perfectly all right. Yeah, okay, you can. আটজন একটা দিলে হবে। আচ্ছা, এরপর দেখি বিসি সেকশনে আমাদের কি হবে। বিসি সেকশনের সি পার্টটা অলমোস্ট এর কাছাকাছি দেখা যাচ্ছে, বাট আগের ড্রয়িং এ মনে হয় একটু কম ছিল। So I cannot essentially say where the A and C located. So I can assume, I'm just assuming this, that let's say C is not as close as A. It is just somewhere before A. But what is going to happen? Sorry, I should have labeled this as C. So let's say the C's point is located here. And for this motion from B through C, what is happening that the object is once again moving to the right direction, because you can see, you should see that from this part to this part of the graph, this is a positive gradient segment, because as x value increases, y value is increasing. So this, for this segment, m is positive, which means the velocity of the object will be positive. Once again, the magnitude of that velocity or magnitude of the gradient will be increased for a certain duration. Let's say somewhere over here. And then the gradient will once again decrease, and it is going to reach up over here for the remaining part of the duration. So that can happen. So if I want to describe segment BC, I might as well write like this, that the object starts from rest, moves in the forward direction with increased velocity for the first half duration, and then decrease velocity for the next half duration. At position C, the final velocity is 0. I mean, or you could mention this from at the first sentence as well. The object starts from rest at B and eventually comes to and moves in the forward direction and comes to rest at position C as well. So you might as well mention the initial and final velocity in the first sentence, or if you just want to write in a sequential order, that's also okay. I'm going to say that description once again. Hear me out. The object starts from rest at position B, moves in the forward direction with increase with with increasing velocity for the first half duration, and then decreasing velocity for the next half duration, eventually coming to rest at position C. Descriptionটা বুঝা গেছে কিনা?
Yes, sir.
কার কোনো কোশ্চেন, কনফিউশন, এনিওয়ান? আচ্ছা, সি থেকে ডি এর জন্য আমরা কি বলতে পারি?
So it moves in the backwards direction. it starts from rest, moves in the backwards direction. At first, yes, sir. At first, it speeds up, and then it moves with a constant velocity.
Beautiful. That is, I'd say, perfectly adequate description for the segment series. So what Ryan just said, if I pick up on his footstep here, he said that he is dividing this segment, as we have seen in our last class as well, that what this graph essentially shows that a small segment initially is having a changing gradient, but for the remaining part of this segment CD apparently is a straight line. So, but for this entire segment, once again, the gradient would be negative, because as x increases, y is actually undergoing decrease. So this is actually once again mean that the object is moving backwards. So the description can be like this. The object starts from rest and then starts going backwards with increasing speed, or you can write increasing velocity at the beginning, and then maintains a constant velocity for the remaining of the duration. I'll say it again. তোমার সবাই গ্রাফটা খেয়াল করো, ডেসক্রিপশনটা বোঝার চেষ্টা করো। The object starts from rest and starts going backwards with increasing velocity at the beginning, and then maintains a constant velocity for the remaining duration. বুঝে গেছে কিনা? Any question? Anyone? If any of you have any query about this whole graph thing, you should ask me. It's important that you get the whole point, because capability of graph is very, very important, and every question is appreciated within this class. There is no silly question. You can ask all questions, no big deal, but it's important that you don't carry your questions with you. The whole reason, whole purpose of these classes is that I come to help to solve your queries. So allow me that privilege. Acha, etukuni amader kar kono question hai, so we're going to move on from this point. The next thing that we have is the third information that we get from any given graph is the area information. Area information, we discussed a little bit about the area information. Area under a graph is always calculated by some variation of y-axis segment multiplied by x-axis segment. Depending upon the mathematical formula, you can have a bit of a variation of this formula. For example, if you have an area of a triangle, this is half into base into height. If you have a rectangle, this is base into height. If you have a parallelogram, this is still base into height multiplied by height. But and then again, if you have a trapezium, we use a lot of trapeziums for convenience's sake. If you have a trapezium, that is actually given by half into base 1 plus base 2. I'm actually writing base 1 plus base 2. It is not actually mentioned by base 1, base 2. I'm just trying to represent that these are the two parallel sides. The two parallel sides length. The two parallel sides length should be added together. And then, so this is basically the two similar quantities should be added. So if you have a trapezium on a, let's say, velocity time graph, both of these horizontal lengths represents some amount of time multiplied by the distance between them. So that would be the height. So this whole thing can represent one axis, maybe x-axis. This whole thing can represent the y-axis. That can happen. So what I'm trying to show you that for any case, whenever we are calculating the area under a graph, we are always multiplying two quantities. Maybe there would be some mathematical constants involved depending upon the shape of the geometry figure that we are handling. But it is always the quantity. In terms of quantity, it is always the quantity obtained by the product of two variables. This can lead to a pretty interesting scenario. So we can have a lot of different graphs for which the area can give us a lot of different information. একটা জিনিস বুঝা লাগবে, সেটা হচ্ছে খুব ইম্পর্টেন্ট। সব কোয়ান্টিটি রেশিও একটা কোয়ান্টিটি ডিটারমাইন করে না, একইভাবে সব কোয়ান্টিটিতে মাল্টিপল আরেকটা থার্ড কোয়ান্টিটি ডিটারমাইন করে না। যেমন একটা এক্সাম্পল দিই, ভিটি গ্রাফের গ্রেডিয়েন্ট হচ্ছে অ্যাক্সেলারেশন, ভিটি গ্রাফের এরিয়া হচ্ছে ডিসপ্লেসমেন্ট অর ডিসটেন্স। আমি যদি এটাকে ভেলোসিটি বলি তাহলে এটা ভেলোসিটি দিব, যদি সেক্ষেত্রে এটাকে আমি বলবো ডিসপ্লেসমেন্ট। এখন আমি যদি displacement time graph জাজ করি, displacement time graph এর gradient কে আমরা কি কোয়ান্টিটি বলি? What is the gradient called for the displacement time graph?
Velocity.
Why not speed?
Because displacement is a vector quantity.
Displacement is a vector quantity. Beautiful. Because I mentioned the word displacement time graph, so its gradient would also be a vector quantity, hence mentioned as velocity. So displacement time graph এর gradient কে আমরা velocity বলতে পারবো, কিন্তু displacement time graph এর এরিয়াটা কি কোয়ান্টিটি রিপ্রেজেন্ট করবে? If you multiply some amount of meter with some amount of second, do you get any actual physical quantity? You might feel like maybe we do, we don't know, because we are learning physics right now, which is a perfectly valid reason. I'm not going to say excuse, it's a perfectly valid statement, but hear me out. There is no such quantity, physical defined quantity, that is obtained by the product of distance and time. The product of distance and time doesn't give us any valid quantity. So the area under dt graph does not practically give us any useful information. You can calculate that, but that's not going to amount up to anything useful. Similarly, if you have an acceleration time graph, this is not actually very widely used for your syllabus, but I'm just keeping the whole discussion complete. I'm trying to have that. If you have an acceleration time graph, the gradient of acceleration time graph similarly doesn't give us anything, because there is no such thing that you are going to get from meter per second square divided by second. I'm just showing you the unit, because the gradient of the acceleration time graph, on the y-axis you have meter per second square, on the x-axis you have second. So if you do the ratio of those two things, you're going to get a new unit of meter per second square divided by second, which is ultimately going to give you meter per second cube, and that is not defined for the useful quantity for anything. So for the acceleration time graph, the gradient doesn't represent anything. However, the area of the acceleration time graph can represent an useful thing. Now I'm going to ask you, what do you think is the area of acceleration time graph? Which physical quantity can be represented by acceleration time graph? Or if I give you the question more easily, if you multiply acceleration with time, what do you get?
Meter per second.
Beautiful. That's what the unit. So how would you define this meter per second in terms of name of quantity? Which
Velocity.
Why not speed? Because acceleration. Okay, fine. Perfectly okay. We could also have speed, because change of speed can also be acceleration. But okay, if we say velocity, okay, but that's not complete. You need something more along with the velocity. Let me show you. Acceleration is given by what? Change of velocity over time, right? Have you ever seen acceleration equals to velocity over time? No, you haven't. So if you do the multiplication over here, what do you get? Change of velocity equals to acceleration multiplied by time. So the area of acceleration time graph actually doesn't give you velocity itself. It actually gives you what?
Change in
Delta.
velocity.
So change of velocity. Now this kind of small itsy bitsy differences might be there, because these are the nooks and crannies of the equation that you might have to know individually, which you don't have to really bother about much. এত কিছু কিভাবে মনে রাখা পসিবল, তোমাদের এটা ফোর্সিবলি মনে রাখা লাগবে না, প্র্যাকটিস করতে করতে এগুলো মাথায় চলে আসবে। সো ইউ ডোন্ট, মানে এটা এগুলো নিয়ে এখন প্যারা খাওয়া বা প্রেশার নেওয়ার দরকার নেই, আস্তে আস্তে এগুলো তোমাদের আয়ত্তের ভিতরে চলে আসবে, এগুলো তোমরা অটোমেটিকলি শিখতে পারো। বাট bottom line, what you have to remember, যে generally speaking, gradient information হচ্ছে y-axis quantity আর x-axis quantity রেশিওর আউটকাম, আর এরিয়া কোয়ান্টিটি হচ্ছে y-axis quantity আর x-axis quantity প্রোডাক্টের আউটকাম। এই জেনারেল ইনফরমেশনটুকু মাথায় রাখতে পারলে গুড, ওয়েল এন্ড গুড। আমি এরিয়া ক্যালকুলেশনের জন্য আরেকটা মেথড, আরেকটা ইম্পর্টেন্ট জিনিস তোমাদেরকে দেখাই, সেটা হচ্ছে let's pick up a good drawn question where we have all the values, so that might be bit easier for us to discuss that of velocity time graph. Okay, this is a good one. This is a pretty good one. Okay, this is a good one. Or maybe if we go for this one, Do we have any further varied graph? The triangle, trapezium, and then maybe trapezium, rectangle, trapezium. Yeah, this is something that I like. Open image. Is this image too small? Yes. আচ্ছা, এই ইমেজটা কতটুকু বড়? তোমরা কি এই ইমেজের লেখাগুলো পড়তে পারতেছো?
Yes, sir.
Someone tell me what is this number?
16.5.
16.5. Beautiful. What is this number?
Minus 13.
Minus 13.
Minus 13. Beautiful. Okay, so we're gonna pick this up. Okay. So আমি এই গ্রাফটা কেন অনেকগুলো গ্রাফের থেকে এই গ্রাফটা কেন বেছে বের করলাম সেটা আমি আলাপ করতেছি। I'm gonna try to show you how we can save time. Saving time is something that you need to learn. It's not that you can choose to learn. In my opinion, you need to learn how to save time. In the exam hall, apart from, I mean, among other all remaining important factors, time is a very valuable resource. You cannot squander time. Now, you might wonder, I cannot take a washroom break. That is the answer to that question is a solid no. You can definitely, I mean, I cannot say yes or no in the answer of this thing. I cannot take a washroom break. Yes. That would mean what? You cannot take a washroom break. Anyway, maybe I was asking the question wrong. You can definitely take a washroom break, because if you have to go to the washroom, if you have that pressure, you are definitely destined to make mistakes in your answers. You cannot do both at the same time, suppressing your biological urges and write correct answers in a good mark scoring way. That's not going to happen. So if you have to go to the washroom, you should go to the washroom after 1 hour duration of the time, which is perfectly all right. But what I'm saying is that time is a resource that you really have to save in the exam hall. So I'm going to help you learn what are the different ways you can save time. I'm going to show you one way over here. It's going to be a matter of choice, and that choice is going to be successful if you are adept in that process. আর আরেকটা জিনিস হচ্ছে, ফিজিক্স পরীক্ষায় টাইম সেভ করার সবচাইতে ভালো উপায় হচ্ছে, মানে সবচেয়ে, maybe it's not for physics. I mean, I believe it works equally for all the science subjects, including biology as well. That's what I think. That don't ever write your answers in full sentences. Your school teachers might disagree with me. Some of you might have come across this whole notion from since your class 8 of your school, that you have to write fully grammatically correct sentences, or else we are not going to give you mark. This is, as far as I can tell, is a complete utter nonsense. The examiners do not look for full grammatically correct sentences in a scientific paper, in a science paper like physics, chemistry, or biology. As far as I know, what they look for are correct phrases, in some cases correct words. For example, in any of the questions where it says state, if you have a question that says state blah 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 blah, in almost 90% or 95% of the cases, they're looking for one single word. If they ask you state what happens to a certain variable as this is happening, you might as well say increase, you might say decrease, you might say remains constant. These are the only three possible words that you can write and score 1 mark if your answer is correct. You don't have to write this variable increases as that happens. You don't have to write that whole shebang. You don't have to. In many cases, a single word can be answered. For example, let's say if the question tells you that state what is the gradient represented by the velocity time graph, you can write a simple word, acceleration. You have to make that spelling correct to score that mark, because that exclusive word is your answer. So if you make a spelling mistake in that word, you're not going to score that mark. But if you write that only word, acceleration, complete word, don't write A, C, full stop, because for those answers, an acronym or short form is not allowed. You have to write acceleration, the whole word, and that you score that mark. You don't have to write the whole sentence. Similarly, for descriptive or explain questions as well, if you write in consequential logical order, that let's say I'm asking you I'm asking you to describe how air resistance happen, describe how air resistance work. Maybe I give you 3 or 4 mark. The idea for air resistance is pretty simple. That is that whenever any object moves to atmosphere, as it moves through the gaseous medium, it occupies its own volume by pushing out air molecules out of its path. Try to visualize this thing. Air resistance but this is coming up as an example for the continuation of lecture. So if you're trying to describe air resistance, this is how I would describe it. That as an object moves to atmosphere, it pushes out atmospheric molecules to make its own space. By Newton's third law, before the air molecules move away, they exert an equal amount of force on the object in the opposite direction of velocity. So আইডিয়াটা হচ্ছে এরকম, মনে করো এটা হচ্ছে একটা অবজেক্ট যেটা অ্যাটমসফিয়ারের মধ্যে মুভ করতেছে। মনে করো অ্যাটমসফিয়ারে একটা পার্টিকেলকে আমি ব্লু একটা ডট দিই, মনে করো এটা হচ্ছে একটা মলিকুল। এই অবজেক্টটা মনে করো এই ডিরেকশনে আসতেছে, এসে এখন এটাকে হিট করবে। The moment this green body is going to hit this thing, let me just select the green body and maybe make the hit. Okay, the moment it will make the hit, this green body is going to exert some force onto this blue air particle. The magnitude of this force, whether this force magnitude is going to be big or small, that's a different issue. But by Newton's third law, this air molecule is going to experience some force towards this direction. Before moving away, by Newton's third law, this air molecule is also going to exert an equal amount of force onto this object as well. And then this is definitely gonna be moving away, giving the big object which is passing through the atmosphere its space. But this interaction is obvious. If the object pushes air molecules will also push the object as long as they are in contact. So as the object moves through, I'm going to start my answer once again. As an object moves through atmosphere, it pushes out air molecules out of its path to make its own space. By Newton's third law, the air molecules exert an equal force on the object in the opposite direction of velocity as they receive from the object. So they exert an equal force on the object as they receive from the object in the opposite direction of the velocity. All the air molecules that the object collide within duration of time individually produces a small force, but the total amount of force can sum up to be a significant value. This is how air resistance works. So it's very simple. It's simple as in, like, I mean, if I try to give you a very physical example, let's say you are trying to run through a playground. If the playground is filled up with people, let's say মনে করো যে কোনো একটা বিশাল জনসভা হইতেছে, মনে করো 7ই মার্চে ভাষণ হইতেছে, পুরা এলাকা ভর্তি মানুষ, and তোমাকে যদি বলি যে 7ই মার্চের ভাষণে তোমার মাঠের এই পাশ থেকে ওই পাশ পর্যন্ত দৌড়ে যেতে হবে, it's gonna be difficult for you because there are so many particles. But if the people are sparse, if there are gap in between and you are blindfolded and you are made to push through in a straight line, you're going to have fewer collisions. So it all comes down to the point that how many particles do we collide and how fast are we colliding with them. So if the object is moving pretty fast, it's going to collide with bigger number of particles per second, and every individual collision would be more fierce, resulting in a bigger air resistance. So the way usually air resistance work is that at lower speed, the air resistance is actually very small. I mean, almost negligible. But as you start to speed up, your air resistance starts to go up exponentially. I mean, the amount of air resistance that you might experience from 0 meter per second to 30 meter per second, the amount of increase of air resistance from 30 meter per second to 60 meter per second is going to be a couple of times bigger. Do you get my point?
Yes, sir.
এই জিনিসটাকে বুঝছো বলাবান যে এয়ার রেজিস্ট্যান্স নিয়ে জিনিসটা বললাম যে ফোর্সের অ্যাপ্লিকেশনটা, এটা আমি এয়ার রেজিস্ট্যান্স হেডিং এ তোমাদের কারো ডিটেইলসে বলবো। বাট হোয়াট আই এম ট্রাইং টু টেল ইউ ইজ দ্যাট ইফ ইউ আর ট্রাইং টু এক্সপ্লেইন এ সার্টেন কোশ্চেন, you don't have to write full sentences. I could write the answer in this manner: object moves through atmosphere, comma, collides with atmospheric particles, comma, receives an equal and opposite force in the opposite direction of the velocity, comma, all the collisions give rise to a big force, comma, this is air resistance. Done. And if there is a 3-mark answer to this thing, I pretty well hope to score all of these 3 marks. I'm not going to write full grammatical sentences to describe the whole question. I will prefer to, as an examiner, I would also expect for an examinee to write correct information, non-repeatedly, and non-contradicting information. You cannot write one type of information at the beginning of a sentence and later in some other part of the answer you write a totally opposite thing. You cannot do that. You need to write individually exclusive, correct, non-repeated information in a sequential order. এটা হয়, এটার পরে এটা হয়, এটার পরে এটা হয়, এটার পরে এটা হয়, আলটিমেটলি এটা হয়। এই জিনিসটা মেইনটেইন করতে পারলেই তোমার ফিজিক্স অনেক ভালো করতে পারবে। ইউ হ্যাভ টু থিংক ইন দ্যাট ম্যানার, যে আমি একটা জিনিস চিন্তা করতেছি, এই জিনিসটা আসলে কিভাবে হইতেছে। তোমার থট প্রসেসের মধ্যে এই সাইকেলটা অনেক বড় হইতে পারে, মেবি জিনিসটা আসলে অনেক বড়। যেমন আমি এখন তোমাদেরকে অনেক লম্বা একটা এক্সাম্পল দিব বোঝানোর জন্য, বাট পরীক্ষায় তোমাকে কখনো অত বড় একটা সাইকেল নিয়ে কাজ করতে বলবে না। বাট whenever you are thinking, your thought process should preferably cover the whole thing. যেমন আমি এইমাত্র এয়ার রেজিস্ট্যান্সের কথা বলতে গিয়ে আমি ফোর্সের কথা বললাম। I could have also talked about the energy conversion. I could have. That would be an additional part of the whole thing. So how does the energy conversion work for air resistance? But আমি এখন বলি নাই because I don't want to give you more information. আরেকটা সিম্পল এক্সাম্পল বলি। Sun is the source of pretty much all energy forms that is available to us on Earth, except for geothermal energy. Say what? Geothermal energy and nuclear energy. Apart from these two resources, all the other form of energy resource that we have available on Earth, solar energy, by thermal, solar heating, or the solar panel light energy conversion, the basic food that we have, chemical energy which is coming from photosynthesis and all, the fossil fuel which was actually made by photosynthesis over 1 million years back, so it was also fed from the sun. All of the energy variation that we have available to us, they are all coming from the sun. Now if you think about it, you need to be able to continue one type of energy conversion which should reach back all the way up to the sun. Let me give an example. Do you guys know what a hydroelectric power plant is? Hydroelectric power plant.
So like we use the downward flow of the water to generate electricity.
Beautiful. And one specific structure is needed for that thing to achieve. What do you call that structure?
It looks like a windmill.
Well, no, that's the turbine which rotates and converts the K of the water into electricity. But to achieve that, we need to produce a dam. I mean, if we have a flowing river, we make a dam to store water. We make a large stockpile of water that is basically like a like a battery, but you are not storing electrical energy within it. You are storing gravitational potential energy, and then we can, as per our requirement, flow water down through that dam into the turbine chamber, rotate the turbine by the kinetic energy of the water, and that turbine rotation feeding the generator can produce electricity. Okay, we're going to discuss this thing in detail, but if you think about it, I mean, you guys have learned water cycle in your earlier levels of science in class 6 or 7. So that's why I'm bringing up this example. Here's the deal. Have a look over here. Let's say this is a hill or a mountain. Here comes down and this is the ocean, or this is the ocean. Okay, this is the level of the ocean. Ocean অনেক বেশি বড় হয়ে গেছে. Let's say this is the level of the ocean. We are trying to make a hydroelectric power plant, let's say somewhere over here. So what we're trying to do is that we're going to make a dam, store water within this part, which would otherwise flow directly through. And then we're going to set up a turbine house over here and allow the water to fall from the very top level of the dam all the way down. So this water is going to convert this GP into K. And as it's going to flow through the turbine, it's going to convert all the portion of the GP into electrical energy, and eventually the water is going to flow down all the way up to the ocean. This is basically how any hydroelectric power plant works. Now my question is, the whole idea of a hydroelectric power plant is that if we can make a hydroelectric power plant in the path of a river, this hydroelectric power plant should be able to provide us energy for a really long duration, because it is considered to be a renewable energy resource, which means it's not supposed to run out. Now, my question is, how do we get an considerable renewables? I mean, why is this a renewable source? The water is flowing down. Do we have an infinite amount of water in on top of the mountain? Why should water be continuously flowing down? How is that? How does that even make sense? Does any mountain have infinite amount of water on top of it?
No, sir.
It doesn't. So how do we have the continuous water flow over here? I mean, where does the sun come from here? This is essentially how it's happening. Let's say sun is over here. Figure not drawn to scale. Let's say sun is over here. Sun heats up the water bodies of the lowlands, oceans, ponds, lakes, whatever. And that produces evaporation. So the evaporation means the water molecules from the surface, they don't boil, they are basically converted into low pressure vapor, water vapor. It produces evaporation. And then again, because of the uneven heating of the sun for different part of the day, or for the curvature of the earth, we have airflow. Certain parts become more hot, which are almost flat, receive the sun's ray pretty much vertically. Certain parts which are curved receive the sun's ray at a more dive over more bigger area because of the angle of the sun's ray. They heat up less. So there is a difference of temperature on the surface of the earth. So we have the wind cycle. So wind actually flows into these air molecules go up because of the heating of the sun, and they form cloud. Then wind takes them into the land. And then this water falls onto the landscape everywhere, not necessarily on the mountain, in three different forms. We can have rain, we can have snow, we can also have শিলাবৃষ্টিকে জানি ইংলিশে কি বলে? What do you call the?
Sir, is it hail?
Hail, exactly, hail. Yeah, HAIL, hail. Yes, thank you. So we can either have a rain. Those clouds actually give us the waterfall by rain or hail, or we can have the snow. And that's basically how this mountain collects a lot of water, and then the water is accumulated within a single stream, which is basically a river. And that's how we can have a dam and expect to have enough water over here for the foreseeable future. In this whole process, this is the source of energy. This is the source of energy that is responsible to work like a huge pump. This sun is causing the water molecules to lift up from here, push it all the way through atmosphere onto the mountain top. So that's where they are getting the GPE all the way from the ocean floor to the mountain top location. So this is a huge height gain, and all of this energy gain by the individual air molecules are provided from the sun. And as those water molecules fall down and eventually they flow down to the mountain stream, that's from where we actually extract a small fraction of that available energy that we call hydroelectric power plants. This is exactly how it works. So basically speaking, if the sun stopped giving us energy, let's say the sun is not there anymore, we'll not have evaporation, will not have airflow, cloud will not be produced, and this reservoir would finish overnight. So this is essentially how your thought process should be, that if I have to think that water hydroelectric power plant is a renewable resource, which means it is never going to finish. So where does the energy come from? It comes from the water that flows from the top of the mountain. Where does the top of the mountain actually get the water flow from? It gets it from the clouds. Where did the cloud form? They were formed by the evaporation of the sun. Oh, so that's where the sun working. The sun is providing the heat energy to the oceans, and the other water, what is the ponds and the lakes and the rivers and everywhere. And it is heating up the water molecules. It is lifting up all of those water molecules by the hot current because of the airflow. And then it is pushing all those water molecules into the land and making them into cloud. So that's basically the way by which the sun is providing the necessary GP for all of those water molecules to rise up from the ocean level to the sky level. And eventually that GP ultimately is converting into the turbines of the hydroelectric power pump. This is how this is a complete thought process that you are thinking the whole scene in a cyclic order. That's how the whole thing is working. So এটা যে সবসময় করা লাগবে বা সবসময় করা যাবে সেটা আমি বলতেছি না, বাট ইউ শুড অ্যাসপায়ার, ইউ শুড ট্রাই টু অ্যাচিভ দ্যাট। তুমি একটা জিনিস যত ফুলি থিঙ্ক আউট করতে পারবা, জিনিসটার আন্ডারস্ট্যান্ডিং তোমার কাছে তত বেশি ক্লিয়ার হবে এবং তত কম এফোর্টে তুমি ওই জিনিসটা ডিসক্রাইব করতে পারবা এবং জিনিসটা তোমার তত বেশি লং লাস্টিংলি মনেও থাকবে। বুঝতে পারছি? I'm not trying to give you a complicated view of physics. This is not about that. I'm trying to give you a holistic view of what your attempt should be towards judging processes, what your attempt should be towards understanding certain things. বিরক্ত হইছো কে? সবাই বিরক্ত হইছো ঠিক না?
Master, it was fun.
Okay, rest of them are definitely bored. Okay, I'm sorry if I have bored you, but this is something that I wanted to get across. I really wanted to get across.
It wasn't boring, don't worry.
So getting back to the point that you don't have to write full sentences, write in phrases, in correct wording, correct sequence, and appropriate points, non-conflicting points, and non-repeating points. Thank you. Non-repeating points একটা কথা মানে হচ্ছে কিরকম, যে মনে করো তোমাকে একটা সার্টেন জিনিস জিজ্ঞেস করলাম যে let's say what happens to a certain quantity as certain other quantity changes. মনে করো 2 নাম্বার দেওয়া আছে, so they are asking for 2 different information. তুমি একবার লিখলা যে this quantity increases, full stop, this quantity gets bigger, full stop. I mean, this doesn't make sense to get, there is no sense to give you 2 different marks, 2 marks for this answer. This quantity increases, this means it gets bigger, but if you write that same thing in a different set of wording, it just gets bigger, you're not going to get 2 different marks. So writing the same information in a different set of wording is not going to be beneficial for you. You have to write exclusively different points, and sometimes that boundary might be a bit haste, it might be a bit gloomy for you, but that's essentially where the practice comes in. The further you're going to practice, the more you're going to try to access the mark schemes and the examiner's report, those alignment, that what basic property distinguishes 2 different information, and why these 2 information are not same, and why these 2 information are same, that boundary line is going to become more clear to you, So okay, I wanted to actually discuss about this question, so I'm going to actually put it down. পোলাবান, আমি একসাথে অনেক কথা বলে ফেলছি, so I'm going to take a small break, 5 minutes. You can also take 5 if you have to take some washroom break or anything, or just walk around a bit, and we'll resume class in 5 minutes. So the area calculation for this process can be either done by the choice of multiple triangles added with multiple rectangles, or you can do by exclusively trapezium, or if you're interested, you can actually do it by the combination of all 3. For example, if I want to save time for this question, this is how I would attempt this area calculation. I am going to try to go for a trapezium for this much, then go for a trapezium for this much, then go for a trapezium for this much. Essentially, I have to go for a triangle over here because I have no other way, and then go for a trapezium. Let me draw that with maybe rainbow color for this whole part. This will give you the smallest number of sections that you have to calculate. But if you don't want to do it this way, you can also go for individual rectangles and triangles as well. So if I go to calculate the areas of the 3 different parts over here, this is going to be what? Parallel sides in this case are horizontal components. So this is first parallel length, and this is the second parallel length for this red trapezium. So this area would be half into 5.5 plus this much should be how much? How much should this be?
2.5.
Here is 5.5, here is 3. Yeah, this is 2.5. And the height would be 15. So whatever that is. Then this one, for this trapezium, here the parallel sides are the vertical sides. So this side is 15. This side is 5. So half into 15 plus 5 multiplied by the vertical distance between the two parallel sides, which is 5.5 through 6.5, which is 1. Then I have to go for this triangle. Triangle is given by half into base into height, so it's very simple. This much is 6.5 through 8 is 1.5. So this triangle should be half into 1.5 multiplied by, so I can use black for writing, multiplied by 5. And then the trapezium, which is this can be written as half into 8 through 16.5, that is 8.5, plus 9 through 13, which is this much, this is 4, multiplied by 13 on the lower side. So these are the individual areas that is covered by this velocity time graph for the smallest number of segments. So I have divided this into 4 segments. We can calculate all of these individual values. So let's go ahead and do that. Give me the value of these areas. How much does this become? Calculate রাখো আমার না পাইছি এটা আসবে হচ্ছে 5 2 7 8 8 4 4 15 60. This is going to become 60. This will be 20 10. This will be, I have to do that, 2.5 into 1.5, 3.75, and this will be half into 12.5, and to 13. That is 81.25. So now if I ask you, if the question asks you, let's say, what is the displacement of this object? What would be your answer?
Is it 0?
I don't know. We have to calculate. This is gonna be 60 plus 10 plus 3.75 minus 81.25. That will be the displacement. Oops. Sorry. However, if the question asks me, what is the distance covered by the object? For that question, we would have to add up all of those. 60 plus 10 plus 3.75 plus 81.25. Try to understand the difference. This part of the segment is on the positive y-axis, which means this represents a positive velocity with different values, doesn't matter. But for this whole part, from 0 second to 8 second, the object was moving in the same direction, faster or slower, slowing down or speeding up, doesn't matter. It was going in the same direction. But from 8 second through 16.5 second, the object was going in the opposite direction. So if you consider, let's say this is your starting point, from 0 to 8, it was going this way. Then from 8 through 16.5, for the remaining 8.5 seconds, it was going the other way. I do not know whether it will eventually reach to the same point. I can say this if I just go ahead and calculate. If you add up all of these numbers, how much do you get from here? আমার এই ক্যালকুলেশনগুলো সবগুলো ঠিক আছে না? আর কেউ কি করছো? এগুলো একটু চেক করে দেখো। Everyone, help me. I might be wrong, so I'd like some.
Sir, আমারও সেম আসছে।
সেম আসছে সবগুলা?
Yes, sir.
আচ্ছা, থ্যাংক ইউ। সো এটা কত আসছে সাবট্রাক্ট করলে? এটা হচ্ছে 73.75, 81.25 minus 73.75, 81.25 minus 73 0.75, which is minus 7.5 meter, and this would be just the addition. So if I just change the sign, 155 meter. Try to understand the significance of these two different answers. Just because this was a vector quantity and this is a scalar quantity, can you appreciate this? Does it make sense? পোলাপান খেয়াল করো, কেন আমি এইটাতে মাইনাস করলাম আর কেন এটাতে সবগুলো অ্যাড করলাম, এটা বুঝা গেছে কিনা? This is the displacement. How far apart is the object from the starting position? And this is about distance. What is the length of path that was covered? So this is the key idea that you have to apply. Now, if I didn't want to do it in these many segments, it would also be possible if you want to go for a simpler calculation process, but with bigger number of segments. I could also do it in this manner. I could have gone for a triangle of this size, then a rectangle of this size, then a triangle of this much size, then a rectangle of this much size, then a triangle of this much size. So if you go for only triangles and rectangles, for this positive velocity segment, you're going to have 1, 2, 3, 4, 5 different area calculation. And then over here for the lower part, you're going to have 3 different area calculation. One triangle over here, one rectangle for this part, and then another triangle over here. So you could also choose to do this in segments of triangles and rectangles if you are convenient, if you feel it convenient. It's going to cost you a bit more time, but if you are not confident for the calculation procedure of trapezium, which you should be, by all means, that's my recommendation, you should definitely try to apply trapezium rule to save time. But if you feel like that this is more safe for you, you can also go for that. I mean, it's always better to take some extra time than to come up with the wrong answer. Hands down, this is always true. You could also do that. Ultimately, you would have the same values provided your calculations. If your calculations are correct, you would ultimately end up with the same values. So এটা হচ্ছে এই ক্যালকুলেশন করা বেসিক। এই ক্যালকুলেশন নিয়ে কার কোনো কোয়েরি আছে কিনা? কোয়েরি থাকলে বলো। কেন এই দুটো ডিফারেন্ট সেটা বুঝা গেছে সবার? Say yes. I would like everyone to respond, either in the voice channel or in the chat channel. If it's no, say no. Yes, বলো, তাইসি বলো।
স্যার আমার কোশ্চেন হলো স্যার একটু আপনার লেফট সাইডে যে ডিটা দিতেছেন ওটার উপর একটা লাইন দিয়েছেন কেন?
Oh, this is how we represent vector quantity whenever we are writing. We can give a bar sign on top. Sometimes vector quantities are represented with an arrow sign on top. These are the way by which we distinguish between a vector quantity and a scalar quantity whenever we write. In the printing case, this can be followed. A bar sign can represent vector quantity, or in some cases, block letter can be also used to represent a vector quantity. For example, a velocity can be represented by a block V, whereas speed might be represented by a simple V. We do not bother to draw block letter for writing cases. For writing cases, this is the more common sign to represent a vector quantity. A bar sign on the top represents vector quantity, and if you don't have a bar sign, it represents a scalar quantity. So in this case, I was meaning this one to be displacement and this one to be distance. That's why I gave the bar sign. Any other question? Apparently no. Okay. One more thing that you might also be interested in, for these examples that we are doing, we always have the graph to have straight line segments. That's why it was convenient for us to go for trapezium or triangle or rectangular segment calculation. What if any of the segment is not actually straight? For example, if we have a curved part within our question for which we are asked to calculate the area, let's say if we have a graph that looks like this, maybe the graph for a parachutist graph, VT graph of a parachutist. So what's going to happen? You, for your level, for your O level, you will never be asked to calculate the area under a curved region. You will never be asked for that. They might ask you some written description for what is happening, but you will never be asked to calculate the area under a curve till your AS level. In your A levels, whenever you will reach up to that level, inshallah, you will have the understanding, and it should be required for you to be able to calculate the area under a curve, even though the equation of the curve is not given. So we're not going to take help of integration. Rather, there is a graphical process that we call square counting. We're gonna do that to find out the area under the curve. So tomader O level say কখনোই ম্যাথমেটিক্যাল প্রবলেমের জন্য কার্ভের আন্ডার এরিয়া বের করতে বলবে না। সো এটা নিয়ে আমাদের বদার করা লাগবে না, ঠিক আছে? আচ্ছা, এইটুকু গেল। The next thing that I usually always teach the students is the VT graph of a parachutist. আচ্ছা, এটার আগে আরো দুটো জিনিস পড়া নিতে হবে, এটা একটু পরে পড়াবো। The speed time graph or velocity time graph, however you say it, because the person is going to always fall downwards. We're going to see this thing. Before that, I'd like to teach you the Newton's laws of motion. Before teaching Newton's laws of motion, I need to teach you what is momentum, because it's going to be required term in the second law. আচ্ছা, মোমেন্টাম নিয়ে আমি তোমাদেরকে মনে হয় 1-2 ক্লাস আগে একটু কথাবার্তা বলছিলাম। মোমেন্টাম ইজ এ ফিজিক্যাল কোয়ান্টিটি that is defined, that is represented by the term small p, that is defined as the product of mass and velocity of an object. I said velocity, not speed, so I can write a bar sign over here representing the velocity vector quantity. So momentum will also be vector quantity, which will have magnitude and direction. So one example can be, let's say if we have an object that has a mass of 2 kg, which is moving towards right at a speed of let's say 10 meter per second maybe, then the momentum of the object should be written as 20 kg meter per second, comma, towards right. And this is actually quite important for many of us to understand, that whenever we are trying to represent vector quantities, it is always important that within that expression of that quantity, we should have the magnitude, we should have the unit, and we should also have the direction embedded within. For many cases of your syllabus, or I could say for most cases of your syllabus, this word direction is actually not given in most cases. Rather, this direction thing is rather embedded for plus or minus, which means if you have an object moving towards right, ideally we consider that to be positive direction. This is very much similar to the coordinate system. তোমরা যে বেসিক গ্রাফের যে কোঅর্ডিনেট সিস্টেম আমরা দেখি, সেই কোঅর্ডিনেট সিস্টেমে অরিজিন থেকে ডান দিকে হচ্ছে পজিটিভ এক্স অ্যাক্সিস, আর বাম দিকে হচ্ছে কি নেগেটিভ এক্স অ্যাক্সিস, ঠিক না, মাইনাস এক্স, আর উপরের দিকে হচ্ছে প্লাস ওয়াই, নিচের দিকে হচ্ছে মাইনাস ওয়াই। এটা তো সবাই জানো, basic Cartesian coordinate system যেটা x axis and y axis. So for the vector quantities as well, we prefer to use a similar idea that any vector for a two-dimensional observation, if it is moving or aiming towards right, we consider this to be a positive vector. If it is moving towards up, we consider it to be a positive vector, and vice versa, which means if anything is moving left, we consider it to be negative vector. If anything is moving down, we consider it to be negative vector. Now this rule of, or this, what can I say, I can say convention, is not actually a rule. This convention of defining the positive and the negative direction is, however, entirely dependent on the person who is doing this judgment, which means this is the most common type of choice that we prefer to make, that is universally common. But if someone wants to judge it the other way around, they're also allowed to do that. But what is important, throughout the entire mathematical model or throughout the entire solution of the problem, that considered direction should be kept constant. So we cannot consider towards right positive in one case, and within the same problem suddenly we've considered that towards left would be positive. That cannot happen. You have to keep the continuity of your consideration throughout your entire mathematical or theoretical process. That's very important. So momentum is defined by this. এখন change of momentum of an object can be written as the mass into change of velocity. So one example can be shown like, let's say we have an object over here which had a mass of m. It was moving towards right with an initial velocity of, let's say, u, and at this point, let's say we are going to apply a force F onto this object, and this F force is going to keep applying on the object. So we're going to keep on applying the same force as the object moves on. So it's not a momentary force. It's a continuously applied force. We're going to push the object, let's say over a duration of t, till the object reaches up to this point of the motion. So we're going to apply this F force for this entire duration t, and let's say when the object reaches up over here, the final velocity of the object becomes v. So how do we work this? I need to move this title a bit lower. তোমাদের 9টার সময় ইয়ার ক্লাস আছে, তুলান স্যার ক্লাস আছে, রাইট?
Yes, sir.
আচ্ছা, হ্যাঁ, আমি
No,
9টার সময় তোমাদেরকে ছেড়ে দিব. No worries there. I'm keeping an eye on my watch, clock, whatever. So the way we can write is that the initial momentum of the object pi is mu. The final momentum of the object is written as mv. You can see over here, I'm not using the bar sign anymore because in many cases we can avoid using the bar sign. We know that this is a vector quantity, but we are bothering not to write vector symbol in everywhere. But what is important that I have represented both of my momentum quantities with positive. So here we haven't given anything, which means there's an embedded positive sign. There is also an embedded positive sign. Having representing both of the momentum as the same sign means the object was moving in the same direction for the entire scenario. So it was always moving to the right, hence we consider the momentum to have the same direction, in this case towards right. So this is the final momentum and initial momentum. So if I write change of momentum, delta p, that should be always given by final minus initial, which would be equals to m into v minus u. Now, if just for the sake of interest, if I want to divide both sides by the duration of time t, let's say I'm going to divide both sides by t. So what's going to happen? Delta p over t can be written as m into v minus u divided by t. If I take out the m from this expression, let's say I'm going to keep the m individually different, so I'm going to write v minus u divided by t. What does this expression mean? Final velocity minus initial velocity divided by time. What does this expression refer to?
Acceleration.
This expression refers to acceleration. Beautiful. So this would be given by acceleration. And maybe you do know that mass into time, mass into acceleration. Maybe you do know. If you don't know, we're going to see about that. This is actually the expression of force. So in other words, I can say that force of an object can be also defined as delta p over t. Force equals to delta p over t. How can we physically describe this quantity? What would be delta p over t? Delta p over t is described, it is the rate of change of momentum. For example, acceleration is given by delta v over t. How do you describe this? It is the rate of change of velocity. Whenever we divide any physical quantity by time, we call it rate. That's the basic idea of dividing by time. So delta p basically means rate of change of momentum, and rate of change of momentum can be also defined as f. To be precise, this is exactly how Isaac Newton defined force. Isaac Newton did not define mass into acceleration as the definition of force. He defined force as the rate of change of momentum. Now, till before your syllabus, the momentum was a concept that was not included in the O levels. So we physics teachers had to teach the kids that force has a very somewhat different actual definition, but for your syllabus level, you are going to define force as the product of mass and acceleration. If you ever write, let's say the question comes in your let's say in your actual exam, a question comes, a 1 mark question comes that define force. So what would you write? You might feel like I can write force is the push or pull on any object. This is a qualitative definition, not so appreciated by the examiners. They might give you mark, but they are more likely, let's say they are 80% likely not to give you the mark for that answer. Although it is a correct answer, but this is something that they do not expect from. If you write force is the product of mass and acceleration of an object, you should get the mark. If I was an examiner, I would definitely give you the mark. But what would definitely score you the mark if you write force is the rate of change of momentum of an object, that would be definitely 100% sure mark scoring answer, because that's how Isaac Newton, who first defined the term force and actually came up with the unit of force, which is also Newton, that's how he defined force. So এই ম্যাথমেটিক্যাল জিবার জাবারটুকু বুঝা গেছে কিনা এই জিনিসটুকু, এটা তোমাদের মুখস্থ করা লাগবে না, বাট মানে ইন দ্য প্রসেস অফ লজিক্যাল সিকোয়েন্স এই জিনিসটা আন্ডারস্ট্যান্ডেবল কিনা?
Sir, I understand how rate of momentum is equal to ma, but why is the rate of change of how do we conclude that the rate of change of momentum is equal to force?
Oh, that is actually defined from Newton's second law, which is I'm gonna come by. Okay, since you asked it already, I might as well choose to show Newton's second law first. Newton actually gave us 3 different laws, and I should actually what would have been a good sequence that I should have defined the term momentum over here, teach you Newton's laws of motion, and then from second law I should have jumped back over here, which I didn't do, my bad. So I'm coming to Newton's second law of motion first. The statement for second law goes like this. হাতের লেখা পড়া যাচ্ছে?
Ji, sir.
Newton's second law is stated in his book like this: the rate of change of momentum of any object is directly proportional to the force applied on it. So what Isaac Newton tells us is that F is directly proportional to delta P over T. This is the law that he gave us. Now, how does this, but in my equation over here, I actually gave F equals to delta P by T. So how did this become this equals to, and this proportion just becomes unequals to? This is what I'm about to show you. We can get rid of this proportionality sign by means of a proportionality constant. So I can write F equals to K into delta P over T. So what Isaac Newton did, he broke down the delta P expression. So he wrote M into V minus U divided by T, which ultimately gives us F equals to K into M into V minus U divided by T, or F equals to K into M into A. Now, this is the equation that he eventually came up with, and from this equation he defined the unit of force. Unit of force was defined from this equation in such a way so that this constant K becomes 1. So what did Isaac Newton do? What he said that we're going to define that much force to be 1 Newton, unit of force 1 Newton, which when applied on a mass of 1 kg will produce an acceleration of 1 meter per second square. So the definition of 1 Newton force goes like this: the force that produces 1 meter per second square acceleration when applied on a 1 kg object is 1 Newton. This is the definition that Isaac Newton gave us for the value of 1 Newton force. What is the benefit of this? You see, if I replace all of these unit values within this equation, I'm going to get a beautiful conversion. So 1 Newton force equals to K constant multiplied by 1 kg of mass multiplied by 1 meter per second square of acceleration. So you have 1, 1, K, and 1. So if you judge numerically, only considering only the magnitudes, you get 1 equals to K. So the unit of force 1 Newton was defined in such a way so that this proportionality constant of this relationship ultimately becomes 1. So if the proportionality becomes 1, what do you get from this line? If K becomes 1, don't you get this expression f equals to delta p over t. বুঝা আছে?
Yes, sir.
And that same thing can be also applied over here. If k equals to 1, if k becomes 1, then this equation actually becomes f equals to ma. These are the most common force equations that you use in a lot of cases. So that's basically from where this expression came by, ma equals to f or f equals to delta p over t. I think this answers your question.
Yes, sir. Thank you.
No problem. I was about to discuss this, but I actually messed up the sequence, but thanks for getting me back on track. This is the Newton's second law of motion, which is a very important law. Newton's first law of motion is actually quite simple. Newton's first law tells us, I'm going to give you the elaborate version of Newton's first law first, and then I'm going to give you a much shorter version, a much more simpler version. And I would recommend that you try to remember the simpler version, because from the simpler version, you can always deduce the bigger version. The bigger version goes like this. Any stationary object will always prefer to remain stationary. And moving objects will prefer to maintain constant speed in a straight line. Full stop. Not full stop, unless force is applied. Sorry, unless force is applied. I'll say it again. I actually messed up a bit. I'll say it again. Unless force is applied, stationary objects will remain stationary, and moving objects will keep moving with the same speed in a straight line. The law doesn't say forever, but it implies forever. So if no force is applied, stationary objects will remain stationary forever, and moving objects will keep on moving with the same speed in the same straight line, which means it will basically maintain its velocity. If force is not applied, it will keep on moving with the same velocity forever. That's the idea of Newton's first law. This is the large version. The simpler version of Newton's first law is that, I'm going to write this down. If this sum, this is this what can I say? This 90-degree rotated M looking sign. This is actually the symbol for summation. The actual printed version looks a bit more beautiful. I might actually show you. This is some symbol. This is the same symbol. This is a big sigma. Yeah, this is big sigma, small big, sigma. This is the big sigma. So this letter actually, I think it's Greek or Latin, whatever. I forget. I always tend to forget. But this is the symbol for that represents the resultant or sum of multiple different things. This is also used in statistics as well. This symbol for the sum of multiple numbers. In vector quantities, this symbol represents the resultant. So this symbol means that if the resultant force acting on an object is 0, it means if the object is not subjected to any unbalanced force. Now I'm using multiple different words over here, resultant, unbalanced. What do these mean? I mean, don't worry. If the resultant force on an object is 0, it means if an object is not subjected to any force whatsoever, then initial velocity and final velocity should be equal. This simple equation basically means it all. It simply means that if an object was stationary, it will remain stationary. If an object was moving, it is going to keep on moving with that same velocity. The first law actually is sometimes called the inertial law of motion. Inertial law of motion means, I'm going to try to elaborate the term inertia with you kids a bit. Inertia is, I mean, this term is going to show up in your motion chapter multiple different times, so might as well take some interest into it. Inertia of an object is basically the tendency of an object to maintain its velocity condition. Or in other words, I can say that the reluctancy of objects to change its velocity. What it means that if an object is at a certain defined moving state, it will always prefer to maintain that state. It will not on its own, without undergoing through any trouble, which is namely force, it will not change velocity. An object will try to always maintain its velocity unless affected by an external force. So this behavior of objects to maintain its original velocity is what we call inertia. Inertia is largely related to mass, because more massive objects has a more stronger tendency towards maintaining their velocity. The more massive an object is, the more force is going to require to produce even the smallest amount of acceleration. Even the smallest amount of acceleration. If an object is small, then you might produce significant acceleration on the object by applying a small force. But the bigger the mass is, the more reluctant it is, or more rigid it is towards changing its velocity. It doesn't want to change its velocity. This idea that objects prefer to keep their velocity constant is what we call inertia. I'm going to show the definition of inertia from Wikipedia so that we can get a more clear understanding. Take a look. Inertia is the resistance of any physical object to any change in its velocity. They've used the term any because they're trying to specify that it might happen solely for magnitude, it might happen solely for direction, it might happen simultaneously for both. This includes changes to the object's speed or direction of motion. An aspect of this property is the tendency of object to keep moving in a straight line at a constant speed when no forces act upon them. Inertia comes from the Latin word iners, meaning idle, sluggish. Inertia is one of the primary manifestation of mass, which is a quantitative property of physical systems. Isaac Newton defined inertia as his first law in his Philosophiae Naturalis Principia Mathematica, which states, okay, I cannot read this. The vista innate forces of matter, a power of resistance by force. Never mind. In common use, the term inertia may refer to an object's amount of resistance to change its velocity. So that's basically it. Is a resistance that an object poses against change of velocity. এটা হচ্ছে inertia কথাটার বেসিক মিনিং। আচ্ছা, এটা হচ্ছে আমাদের ফার্স্ট ল। এখন এখানে আরেকটা জিনিস আছে যেটা এই ফার্স্ট ল সেকেন্ড লকে অ্যাকচুয়ালি কম্বাইন করে। এটা তো আমাদের সিলেবাসে আছে কিনা আমি ঠিক শিওর না। সিলেবাসটা আমার প্রিন্ট করানো দরকার, প্রিন্ট করায় হাতে রাখা দরকার। আচ্ছা, I'm not sure if this other part that I'm trying to talk about, which is তোমাদের ওলেভেলস আছে কিনা, থাকুক বা না থাকুক আমি তোমাদের তারপর দেখাচ্ছি। তার কারণ হচ্ছে যে sometimes examiners set up questions like that. আমরা চাইলে নিউটনস সেকেন্ড ল থেকে ফার্স্ট লটা ডিরাইভ করতে পারি। So in other words I can say that first law can be considered to be a derivative of the second law. Let me show you how. Second law এর basic concept হচ্ছে F equals to ma. This is the mathematical expression of second law. Force exerted on an object can be expressed as mass times acceleration. And the first law's expression is that if the resultant force on an object is zero, then initial velocity and final velocity should be zero. So what we're going to try to do, we're going to try to get to this sentence starting from this equation. এই ইকুয়েশন থেকে আমরা এই সেন্টেন্সটাতে রিচ করার ট্রাই করব। Let's have a look if it is possible. So I'm going to write this equation in terms of resultant force. So resultant force on an object is given by mass times acceleration. If you wonder যে এখানে হঠাৎ করে কোথা থেকে resultant force চলে আসলো, এতক্ষণ তো শুধু f ছিল, এখানে resultant force সিম্বলটা আমি ইচ্ছা করলে আনতে পারবো। The idea is actually in this case yes, because if you go for my mathematical example, I told you that this is the object that was moving by in a straight line. We applied one force on this object in the horizontal direction to the right. I didn't mention any other force, which means if you want to consider all the forces in this example, basically there is one force. Or just for the sake of understanding, I could show you that this is the resultant force, which basically means that even if the object is subjected to multiple different forces, maybe there is a bit of an air resistance, maybe there is a bit of a weight, maybe the object is going over some rough plane, but if you combine all the forces that this object is experiencing and convert everything to a single resultant force, this is the resultant which is working horizontally to the right. That's also perfectly okay. So that's why I can write the symbol resultant symbol over here just because it's needed. So resultant force equals to ma. Now the first law states that whenever resultant force is 0, v equals to u. So I'm going to apply that if logic. So if we apply this resultant force to be 0, I can write 0 equals to ma. Now one thing you need to understand, whenever the product of two different variable is 0, either of them has to be 0, right? You know this from math. ঠিক কি না?
Yes, sir.
এখন একটা অবজেক্টের ম্যাস কি 0 হতে পারে?
No.
Obviously একটা অবজেক্টের ম্যাস কখনো 0 হতে পারে না, তার মানে ম্যাস 0 হবে না। তাহলে obviously therefore since mass is, I can write because no 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 কই লিখতেছিলাম, হারাই ফেলছি। আচ্ছা এখানে লিখতেছিলাম। So I should write because this is the upside down therefore m is not equals to 0, therefore acceleration must be 0, and acceleration 0 হওয়ার মানে কি, v minus u divided by t equals to 0. If I just cross multiply, I'm gonna get v minus u equals to 0. Ultimately I get v equals to u. So there you go, we have the conversion of the first law from the second law. How? We applied the logic. When resultant force is 0, this will lead to v equals to u. That was the key statement mentioned in the first law of Newton. So in other words, we can say that the first law of motion can be deduced from Newton's second law. এই এক্সাম্পলটা বুঝা গেছে কিনা?
Yes, sir.
আচ্ছা, এরপরে আমাদের যে ইকুয়েশনটা আছে সেটা হচ্ছে নিউটনস থার্ড ল। আমি থার্ড লটা তোমাদেরকে আজকে ক্লাসে পড়াবো না, কারণ থার্ড ল ইটসেলফ একটা বড় একটা জিনিস, এটা অনেক ডিটেইলস আলাপ করতে হয়। আই এম অ্যাকচুয়ালি প্রিটি ওয়ার্ন আউট, আজকে একদিনে অনেক কথা বলছি। তোমাদের এখনো 5 মিনিটের মতো টাইম আছে। For those of you who have class, take a 5 minutes break, refresh up and do the class at 9. For those of you who do not have a class, have a good life. আজকে মতো ক্লাস শেষ, খোদা হাফেজ, আসসালামু আলাইকুম। তোমাদের কোনো হোমওয়ার্ক দিতেছি না, তোমরা এগুলা নিয়ে পড়াশোনা করো, যদি বই থাকে বই থেকে পড়াশোনা করো, no big deal. If you get something that you want to ask from within the discussion that we have, I'd really appreciate this, that if you do take some time, read through some of your textbooks or any other materials that you get your hands on, and you do have some you have some relevant question, I'd really appreciate if you ask me questions in the next class. And like I said in the our introductory class, that any question from any source, be it your school, be it your home tutor, be it your other physics teacher, doesn't matter. Any question regarding physics that applies to your chapter, that applies to your understanding level, are always welcome. Any question is welcome. All questions are welcome. So thank you. Assalamu alaikum.
Assalamu alaikum.
Assalamu alaikum, sir.
Hello.